And now I'm honored to invite Arya Bhatt, the CEO of PreciseBio.
Good afternoon, and thank you, Nachum, Daphna, and Anat. I'm happy to be here again. I'll start with a short movie, and I'm sure the MDs here will definitely appreciate this. What I'm showing here is the transplantation of our 3D biofabricated, bioprinted cornea in the animal model. This is done by Professor Michael Maimoni from Rambam. And what you're seeing here is really a cornea from human cells, biofabricated in the lab, where here it's very unique and from several aspects. First of all, this is a quality controlled tissue. It's being tested for viruses, fungus, etc. Has very high cell density. It's very thin. We're talking about a 12 micron thick tissue, and with outstanding mechanical properties. I think this is one of the main things that every MD here in the room or whoever is watching this says, okay, when can I get it? Because as you're going to see now, it's very simple to transplant. And this whole procedure that I'm showing now is a minute and a half. And what's really amazing is what you're going to see now, how it just opens up. And think of when you compare it to a DMIC, which is scrolled up, and you have to tap it and damage the cells. Here, essentially, we're done. You can see also the S mark there. And essentially, that's how simple it is. So I'm sure that the MDs, when they see this, and I'll just complete it with the rebubbling, it's really an amazing tissue and product. This is fabricated, and I'll show it now in just shortly, part of the fabrication. What you're seeing here is our printer. You can see there we're printing two in the middle, two corneas in parallel. Four more are waiting here in the inspection. And this is done essentially, think about it, Control P, less than 2 minutes and you have a cornea. Controlled, biofabricated. This is our software, where you can see also the inspection that we're doing inside the process. And this is the printer that is already being moved into the GMP facility and starting for the production for the clinical studies. I'll step back now and a few words about Precise. Essentially, we have a unique technology, and our technology is with a very strong IP, and it's really a platform. I mean, and I'll show here also retina tissue, and essentially it's a platform that can move from indication to indication, supported by very strong IP. As mentioned here already by Nachum, we have a strategic collaboration with Zeiss, really an amazing partner, commercial agreement and investment by Carl Zeiss Meditech. We have 3 products on the path to the clinic. And what's important to say when I mean on the path to the clinic, we submitted at the beginning of October our pre-IND, and at December we received and we had the meeting with them. Essentially, it's a go-ahead on the product, on the biofabrication process, the QC, the clinical, first clinical study. Essentially, we're in line with the FDA, and in 2024, we will start our first in-human study. And up to date, the company has raised over $35 million, and we are currently in the middle of our B round. We started out with a unique printing technology, essentially laser technology that has unique capability to print cell by cell. When you think of a tissue, the fact that you can deposit cell by cell essentially enables you to mimic the anatomical structure of the tissue as it is in the body. In the cornea, for example, it comes out in effect that we have very good cell density. And this is really a unique technology that has been developed by the company. But in addition to that, there's, on top of the 3D printing, there's also the cell technology that we have the capabilities, the biomaterials, which is not less important, bioengineering, how we connect cells to collagen, to other materials, and of course a lot of engineering really to bring this forward. We're today focused in the ophthalmology field, but as I mentioned, we're really a platform technology. We have several products in the ophthalmology, and I'll show now briefly some of them. So this is the cornea, and as you can see here, here we damaged the endothelial layer, and you can see here after 3 weeks, a clear, transparent cornea, and you can see also in the OCT the thickness, maintain the thickness, and not less important, the cell density here is over 2,500 cells per square millimeter. I'm sure that everybody that can appreciate that number after 4 weeks in an animal's eye. Also here with the follow-up in vivo, the cells, the identity of the cells, the potency of the cells, and of course on the left you can see the thickness of the cornea, which all essentially lead to a very good functional tissue. The second tissue that I would like to show is our retina tissue, and this of course under the guidance of Professor Anat, and here you can see after 2 months in a porcine eye, fully integrated, very good integration into the porcine model. And here we can see the human cells inside the eye and the pathology, functional from the biological aspect. Okay. So those are just 2 of the tissues, and I'll jump to the end. What's I think the most amazing in Precise is our team, where we have a biology team, physics, software, electronics. You can see here Professor Gilad doing the retina transplant, materials team, and in addition on top of that, the QA, QC, RA, etc. Thank you all for your attention, and